Good evening, viewer. Welcome to our Glory Globe TV. Here's the breaking news. Yes, the chemical origin of life on Earth is a puzzle that scientists have been trying to piece together for decades. Many hypotheses have been proposed to explain how life came to be and what chemical and environmental factors on early Earth could have led to it. A step required in a number of these hypotheses involves the abiotic synthesis of genetic polymers, materials made up of a sequence of repeating chemical units with the ability to store and pass down information through base pairing interactions. One such hypothesis is the RNA, ribonucleic acid world hypothesis, which draws from the concept and suggests that RNA could have been the original biopolymer of life, both for genetic information storage and transmission and for catalysis. However, in the absence of chemical activation of RNA monomers, studies have found that RNA polymerization would have been inefficient under primitive dry down conditions without specialized circumstances such as lipid or salt assisted synthesis or mineral templating. While this does not necessarily make the RNA world hypothesis less plausible, primitive chemical systems were quite diverse and could not have possibly been as clean to just contain RNA and lipids, suggesting that other forms of primitive nucleic and polymerization may have also taken place. One of the major hypotheses suggests that perhaps a different type of nucleic acid termed pre-RNA could have preceded RNA on early Earth. Thus, a potentially promising way of investigating the origins of genetic polymers is to not only focus on synthesis of RNA under prebiotically pulsable conditions, but also investigate other currently unknown mechanisms of prebiotic synthesis of non-RNA nucleic acid that could have existed on early Earth, such as copolymerization of monomers of alternating nucleosides analogs with linker molecules. A team of researchers from Tokyo Institute of Technology led by research scientist Ralkin Wei took up the task of examining such copolymerization in a non-RNA based prebiotically relevant genetic polymer candidate. In their recent breakthrough published in Chemical Communication, the team explored alternating copolymerization of glyconucleic acid, that is called GNA monomers, with substituted and unsubstituted dicarboxylic acid, that is called DCA, under primitive dry down condition to produce both linear and branched xeno nucleic acid copolymers. Research suggests that putative pre-RNA molecules could be assembled from monomers with linkers that potentially serve to conjoin other functional polymers to form macromolecular hybrid structure. Explained Dr. E. This additional chemical interconnectivity not only increases the complexity of the polymers but also may have imparted them with novel or emergent functions. Such polymer co-synthesis can potentially help trace the origin of primitive genetic molecules back to an era before enzymatic catalysis or RNA. Behind the report, Glory Globe TV, Delhi.